Welcome to the video on discrete random variables, brought to you by October the cat. All right, so we're going to start by talking about random variables. Random variables are exactly what they sound like. They're variables, x, y, very frequently are random variables. They're variables, but they're random. So normal variables, right? X equals 4. Right? X represents a number, but we just don't know what the number is. That's what normal variables are. But here we're going to talk about variables that are now random. So not only are these letters representing numbers, they're representing numbers and we don't know what they are. There's a chance they're 3, a chance X could be 5, a chance X could be 6. And these are all probabilities for what this variable might be. And random variables are great for talking about life because life has randomness. Okay, so that's what we're going to kind of talk about here. Let's get into it here. So let X be a random variable, and this random variable can represent each possible outcome. Okay, there's a set of outcomes, there's a sample set, there's probabilities. There's a lot of kind of behind the scenes stuff with this, but let's not go too far into it for this intro class. Let's just kind of talk about this. So let's look at this example. We have a cafe and they're observing the following distribution for the number of cups of coffee they sold in a day. So, right, looking at this, there's a 5% chance, a probability of 0.05, a 5% chance from their records that they've examined, there's about a 5% chance that they sold 30 cups of coffee in a day. There's a 20% chance that they sold 36 cups of coffee, and there's a 25% chance that they sold 42. All right, maybe they looked at their data for a week or something. I don't know. It's made up data, but so in this case, this is a probability distribution. It shows all the values. This is all the values that the variable can be, right? X here is just going to be the number of cups of coffee in a day. Number of cups sold in a day. And we don't know what X is. Sometimes it's 30, sometimes it's 36, sometimes 42. You get the idea. And so we can look at the probability that X is something specifically. And that's what part A is asking. What's the probability that X, our random variable, is 36? So one more quick comment before we get too deep into this problem is looking at probability distributions. Probability distributions are just ways of describing how probability works. So the most important thing is that each one of these probabilities has to be between 0 and 1. It doesn't make, I'm kind of drawing off the board again. It doesn't make any sense to talk about a probability of 150%, right? 100% is the biggest a probability can be. 0% is the smallest a probability can be. And they should also add up to 100%. So add to 1 or 100%. Those are the two requirements that we're going to talk about anyway for probability distributions. And probability can go really, really deep, really, really in depth. I took 3/4 of graduate level probability, which uses letters and numbers and words that you've never seen before, that I had never seen before. It's bizarre, but basic. Let's stick to the basics. What's the probability that the cafe sold 36 cups of coffee? So here's how we write that. The probability that the number of cups of coffee sold in a day, right? We said that's X. A random variable, it's a variable, it represents a number, but we don't know what that number is. What's the probability that random variable is equal to 36. This is how we write it. And so we just consult our table. Well, 36, that's up here. What is the probability? Well, 20%. 0.2 or 20% is our answer. You can always express it as a decimal or a percent. And that's what we're doing here with discrete random variables. And we can do this some more utilizing what we know about probability from the previous unit. Okay, we know a couple rules about probability. So in the second one, we have OR. Remember, or addition, multiplication, I don't know. OR means addition, as long as they're mutually exclusive. Is it possible to sell 36 cups of coffee in a day and have sold 48 cups of coffee in a day? Well, I guess at one point in the day you would have sold. No, it's not. It's one or the other, right? These are mutually exclusive. So the probability that X is equal to 36 or that X is equal to 48, since they're mutually exclusive, it's just going to be each one added together. Right? This is because they're mutually exclusive or disjoint. We also use the word disjoint. Wait, hold on. I just wrote down. I can't talk and write at the same time. Because they're disjoint or mutually exclusive, you can use either word you want. All right. And so we just consult the table. That's 20% plus 15% for a total of 35%. And again, I will accept either answer. And we can keep on going through this way, right? What's the probability that we sold at least greater than or equal to at least 48 cups of coffee? Well, that's going to be 48 or greater. Combine all of these things. That's going to be 50%. Okay. It's going to be 0.15 plus 0.35, 50%. And again, since these are all disjoint, mutually exclusive, we just add up everything that's at least 48. What's the probability that the cafe sold at most 36? Well, that's, again, at least means X greater than or equal to. At most, that's less than or equal to. This is the probability that X is less than or equal to 36, and we do the same thing. I'll add up all the probabilities for 36 and lower. That's going to be 25%. There we go. How many cups can they expect to sell on average? On average, average has to do with a mean. What are we expecting here? And I'm not going to go too long into where this comes from, but I'll mention it a little bit. On your next page, let's not get into that. On the next page, we have some formulas. And one of them is the expected value or mean. We'll use both words interchangeably. Okay? Mean, expected value. Okay? And again, this right here represents the population mean. Sometimes we'll look at empirical means or sample means, X bars. But here, we're just going to worry about population means for now. Although in this case, this really would be more of a sample mean, but I don't want to split hairs on this so far. The mean or the expected value, right? This right here means mean mu. This right here means expected value. Means that we multiply all the values of X by their probabilities. And then we add them all up. That's what this notation means. Multiply values x with their probabilities and add them up. This means add. Add everything. Okay, so let's see if we can use this formula. Let's multiply all the x's by their probabilities and add them up. That's going to be our mean. This is asking, what is our expectation? What is our mean? So we're going to sum up all the little x's times the probability of those little x's. And if I need to update the sheet again, but technically, right? Technically, this should be a little x, not a big X. But I wouldn't worry about that if I were you. It's not something I'm going to be grading. But if you're curious, so let's just do this all. Multiply all the x's by their probabilities. So multiply these two together. The x is how many cups? The probability, 5%. So 30 times 0.05. And so on. Okay, 30 times 0.05 plus 36 times 0.2 plus the next x value is 42 at a 25% chance. All right, so 42 times 25%, and so on. 0.48 times, no sneezing in class, Jason. Actually, sneezing is okay, 35%. Wait, is this right? Did I write my data right down? 48 is 15%, and 60 is 35%. And there shouldn't be a 0 here. I'm losing my mind. Again, talking at the same time as writing. Plus 60. 60 has a probability of 35%. So let's check our work here real quick before we go on, right? These should all be the x's. Right? These are all the x's. And then we should also have all the probabilities, 5%. Add that 25, add that 50, add that 65, add that 100%. So make sure they all add up to 100%, and we have all the x's. Technically, these aren't percents, these are probabilities, but oftentimes we can think about them that way. And then add this all up, type this all up on a calculator, and you get our answer. But as you might be able to expect, in this class, we're going to be using computers. So it can also be a good idea. You can organize your information in a spreadsheet. And we'll do this a little bit more in later videos, but we can have one column for all the x's and one column for all the probabilities. So I'd highly recommend that you pause the video right now, pull up a spreadsheet, Excel, Google Sheets, something else, but pull up a spreadsheet. Now in the spreadsheet, let's write down all the x values. Okay, the x values were 30, 36, 42, 48, and 60. And their probabilities were 0.05, 0.2, 0.25, 0.15, and 0.35. So now we're told to find the expectation. Just multiply all the x's times p of x. So let's have a column for x times p of x. Now type the equal sign. See, it's already, Google Sheets actually already predicts it. You can just press tab to do what it predicts, or you can click on this box and say, I want to multiply, put an asterisk, click on this box. And there we go. It also automatically suggests that we drag this down. You can hit autofill, no problem, or you can manually click this bottom corner of the box and drag it down. So these are all of the individual results. The first one is this one. The second one is the next one, and so on. Okay. And we need to add them all up. So one thing that we can do is just add them all up right here. Equals. See, again, it automatically suggests SUM parentheses. And just hold and click these cells and the parentheses. And this is our expected value. This is the expected value of our random variable x, 47.4. So we could say, on average, we expect to sell about 47 cups of coffee a day. Okay? Very important when you're answering questions. To include the units. The units, well, let's write that down on the next page with the formula. The units are always going to be the same as the units of x. So in this case, the units of x is the number of cups sold in a day. So for the mean, it's also going to be cups sold in a day. All right, I'll write that down somewhere. We'll use green. Why not? The units for the expected value and for the standard deviation are the same as the units of x. All right. So variance and standard deviation are the same concepts that we've talked about before. The difference now is that we're scaling it by probability. So we're still adding up all the variances from the mean and squaring them, but then we're also multiplying those things by their individual probabilities so that it can scale depending on the likelihood. So we're going to calculate the standard deviation for this problem using our spreadsheet. So there's a typo here. This is the actual formula for standard deviation. I would recommend never using this ever. If you wanted to just erase that all out, go ahead. Okay, let's just find the variance. And once we find the variance, we'll square root it to find the standard deviation. Okay, let's find variance first. Sigma squared first. And then let's find the standard deviation sigma afterwards. So sigma squared, right, is this thing. Let's do this step by step. What does this mean, right? This means look at all the deviations from the mean and then square it and then multiply each one of them by its probabilities and then add it all up together. So there's a lot of steps, and we're just going to do each one of these steps one at a time. So first, and we're going to use a computer for this, let's just look how far is each value from the mean. X is just the value of a random variable. How far is each value from the mean? Well, let's look at that. X minus the mean. Well, type the equal sign. Here's the X. How far is that? Subtract out our mean. Now be very careful. We're going to be dragging things around. And if we write it like this, then when we drag it down, we drag down all the way. And there's no numbers here. We want the mean to be the mean for everything. So the way that you do that in Excel is put dollar signs. Dollar signs before the column and before the row. And now, when I drag this down, or what if I want to use the autofill? Now when I drag this down, and we don't want this one, look, it's subtracting X from the mean. This cell is not changing, but this cell is, which is exactly what we want. Okay? So we've done this first step. Now we need to look at what is this deviation squared. So now let's just take that answer and square it. So X minus mu squared Well, that's just going to be, what is x minus mu, which we just found, caret 2. That's shift 6 for that caret. We're just squaring each result that we just got. And again, we can autofill, but we don't want that bottom column. Let's write this as sum. And then we can go one step further. What's the next step? Well, each one of these, after they're squared, needs to get multiplied by its probability. So now let's say, okay, this over here is going to be x minus mu squared times its probability. So what do? Type equals. Here's x minus mu squared. Multiply that by its probability, which is right here. And you guessed it, we're just going to drag this down. You can also use the Control D. Or if you don't want to remember Control D, you can drag the bottom corner of the box down like this. And this scales it for probability. And lastly, add them all up. That's what the sum thing. So there we go. If we add them all up, then we're done. So just like before, we're just gonna, there we go. It knows what we want to do. So this over here, this is the expected value. This sum over here is the variance. Variance is 104.04. The variance is less useful, but the standard deviation is the square root of the variance. So to take the square root of that, type equals SQRT. And you can either click on this or add the parentheses yourself. And we want to take the square root of this, so click on this box and the parenthesis, press enter, and our standard deviation is 10.2. There we go. We have used a spreadsheet to help us calculate a standard deviation. It's about 10.2. Actually, I think it's 10.2 exactly, maybe. I can't do math in my head. I think it's 10.2 exactly. And what are our units? The same as x. So the standard deviation is about 10 cups of coffee. Which means on average, let's combine our answers. On average, we sell about 47 cups of coffee, plus or minus 10. That's how we can combine these terms. The average is 47, and the standard deviation is 10. So on average, we sell 47 cups of coffee, somewhere over here. And yeah, usually it'll be within 10 or so is a usual day. We'll talk more about standard deviation because there's a lot of fun stuff. And this is kind of just an introductory thing. Lots of information in this introductory video, pretty long, but we're going to do some examples in the next video if you want to, and we'll really hash out these concepts, okay? Good luck. Let me know if you have any questions, and enjoy discrete probability. I don't have a cat at hand to show you, so you're just going to have to say goodbye to me.